So I just wanted to make another quick little video today to go through a couple more examples of the cross product. Again, this is my preferred method. If this is not your preferred method, you do not need to use this method. Sorry for the writing. I have yet to find a pen that I can actually write on my iPad with. So I'm going to start with a couple examples. So example 1, find u cross v given u is equal to 2, 1, negative 1, and v is equal to 1, 2, negative 3. Now in order to do this, we know we need to start with that second component here. So 1, negative 1, 2, and back to 1. Now I am putting u on top because I do want to do u cross v. We're going to do the exact same thing for v, so we're going to start with that second component, 2, negative 3, 1, 2. I do need to start going down and to the right, followed by down and to the left. So u cross v is equal to 1 times negative 3 minus 2 times negative 1, negative 1 times 1 minus 2 times negative 3, and my third component is 2 times 2 minus 1 times 1. Simplifying this even more, I have 1 times negative 3, which is negative 3, minus 2 times negative 1, which is negative 1. So negative 3 plus 2. My second component, negative 1 times 1, which is negative 1, minus 2 times negative 3, which is negative 6. So a negative 1 plus 6. And my third component is 2 times 2, which is 4, minus 1 times 1, which is 1. And I get 3. So just to refresh your memory, we just found u cross v. So basically that means what we just found is a vector that is perpendicular to both u cross v. And if we wanted to find the length of that vector, we could take the magnitude of this, and that would also give us the area of the parallelogram made by vectors u and v. So in this last example here, we are finding u cross v and v cross u. So I'm not necessarily going to calculate both of these. I do want to calculate v cross u just because that's not normally what we do. So this time we are going to be starting with vector v and the second component. So negative 1, 3, 1, negative 1. And now the second component of u, 2, 1, 0, 2. I am going to be calculating my cross product like normal. So negative 1 times 1 minus 2 times 3, 3 times 0 minus 1 times 1, 1 times 2 minus negative 1 times 0. And if I go one step further, negative 1 minus 6, 0, take away 1, and 2 minus 0. Now I'm just quickly going to tell you, if you were to do the work for u cross v, the vector that you would get is 7, 1, negative 2. Now, this is the total opposite vector. This should make sense to you if you think about the right-hand rule and everything that we've learned so far. U cross v and v cross u would be the exact same vector, just in the opposite direction.